So in this lesson now, we start focusing on the inscribed angle and arc relationship. So first off, what do you notice about the central angle, so our angle in the center, and now what we're going to call the inscribed angle, which is the angle where the vertex is now on the circle. Well, notice here, our central angle is 130 degrees. The arc it creates, CQ, therefore, would be 130 degrees. Well, what is the measure of the inscribed angle that also creates this arc? It is exactly half of the arc and central angle created. So again, notice here, we have our central angle, which is 180 degrees, creating the arc of 180 degrees. But then our angle here, which is on the circle, is 90 degrees, exactly half of the arc and central angle. So again, that is now the relationship. When you have an inscribed angle, which is the vertex is now on the circle, it is exactly half of the central angle. Now, another concept we're going to also keep in mind today is if we have two inscribed angles, so like angle A and angle B. Now, notice though that both of these inscribed angles create the same intercepted arc. So if that is the case, if they create the same arc here, then the angles are congruent to each other. So here in example 1, just to practice, right? Notice how this is an inscribed angle, so it is half of the arc. So that's why here the measure of A is 68 degrees. So then here, you're given the inscribed angle, which is 17 degrees. So now we need to double it. So A is now equal to 34 degrees. Now, here we can't find the angle until we figure out the arc. Well, if we're given two of the three pieces, if you recall, all has to add up to 360. So subtract our two arcs here from 360. You get 124 degrees. So A is 124 degrees. And again, they add up to 360, which means now the angle, our inscribed angle, is half of the arc it creates, our intercepted arc, which is 62 degrees. So that is the measure of B. So now our last one here. Notice this intercepted, our inscribed angle creates arc LM. And this inscribed angle here, that's 3B, also creates LM. So I know that people just want to go, okay, let's set them equal to each other. But why do we set them equal to each other? Because they create the same intercepted arc, making them congruent. So again, make sure you know that why. So we've got 5b minus 7 is equal to 3b. And now we're just going to go through and solve. Again, I'm going to leave this alone and subtract 5b from both sides. Here I've got negative 7 is equal to negative 2b. Now to solve, divide by negative 2. And you get b is equal to 7 over 2 or 3.5 if you want to write it as a decimal. Go and pause the video now and try these U-tries on your own. Here we go. So for the first, AOB, this central angle is given to us. It's 56 degrees. So the central angle of 56 degrees is given to us. We are looking for the measure of angle ACB, which is an inscribed angle. Now, notice that they do create the same arc here, right? So can we state that ACB is also 56? No, they're not congruent. because this is a central angle, right? ACB was the inscribed angle. So if the central angle was 56 degrees, then the arc AB is also 56 degrees because central angle congruent to the arc, which means then what do you have to do to find the measure of the inscribed angle? Divide by 2. So that's why here the measure of angle ACB is 28 degrees. So then 1B, you're just looking for the value of x. Now here, you're given EDF, this angle here is 2x plus 3. Notice how it creates arc EF. And F or EFG, this intercepted or inscribed angle, also creates the intercepted arc of EF. So again, why are you able to set them equal to each other? Because they create the same intercepted arc, they are congruent to each other, the inscribed angles. So 2x plus 3 is equal to 75 minus 2x. Now we go through, gather your variables, right? So I'm going to add 2x to both sides. I've got 4x plus 3 is equal to 75. Now you're just solving your two-step. Subtract 3, 4x is equal to 72. Divide by 4, and you get x is equal to 18. And that is the final answer because we were just looking for x. Then here, the measure of angle, CED. So CED is an inscribed angle creating arc CD, which is 66 degrees. So again, to get the angle measure, divide by 2. So the measure of angle, CED, is 33 degrees. Then the last part, you're looking for arc DEA. So D, here, I'll erase this. So DEA, which if you notice is created by the inscribed angle ABD, which is 96 degrees. So now you got to take that 96 degrees and double it because it's half of the arc it creates. So the arc here is 192 degrees. So our last type of angle that we're going to talk about today that can be created on the vertex is when you have a tangent line, right? So a tangent and a chord. Notice how the vertex here of this angle created is on the line, so or on the circle, which means we can still treat this as an inscribed angle as well. So this angle is still half of the arc it creates. So here, all we have to do is just take that 256 and divide by 2, making our angle here 128 degrees. Now, we do need to pay attention though, because now notice here we're looking for A and B. However, 144 degrees represents this arc over here. So what do we have to do to figure out the other arc? Subtract from 360. So when you subtract 360 minus 144, arc that represents B is 216 degrees. Now notice this angle here is what is creating this arc. So now we can take this 216 and divide that by 2. So here A is 108 degrees. So go ahead and pause the video and try the U-try here on your own. And here we go. So you should have noticed that the arc given to you, the 224 degrees, is on the other side of what the angle, the intercepted arc that angle A creates with the tangent and chord. So that means you had to first find B. So subtracting your 360 minus 224, you end up with an arc measure of, so B is 136 degrees. Now take that 136 and divide that by 2 to get your angle measure of 68 degrees.